Hello friends, today's question. A boy's catapult is made of a rubber cord which is 42 cm long with 6 mm diameter of cross section and of negligible mass. The boy keeps a stone weighing 0.02 kg on it and stretches the cord by 20 cm by applying a constant force. When released, the stone flies off with a velocity of 20 meters per second. Neglect the change of area of cross section of the cord when stretched. The Young's modulus of rubber is closest to. So in this case we are going to make use of the conservation of energy, and from that we are going to find out what will be the value of K, and then we are going to find out the Young's modulus of elasticity. Okay, because we know relationship between K and Y. K is equal to Y multiplied by area of cross section divided by the length L. Okay, so in order to find out Y, the only unknown thing is K. Area is given to us and length is given to us. Okay. So let us first of all find out what will be the kinetic energy of the stone. Kinetic energy of stone. So when released, it travels with a velocity of 20 meters per second. So we can write the stone gains kinetic energy when released, and the formula for kinetic energy is K is equal to half mv square, where m is the mass of the stone, and v is the velocity of stone, So we substitute the value. Mass of the stone is given as 0.02 kg and it is given as 20 meters per second. So we get kinetic energy is equal to half mass is 0.02 multiplied by 20 and whole square, and this comes as 4 joules. And the potential energy is because of the change in the position of the stone because of the stretching. So we can call this as a elastic potential energy of the cord, rubber cord. Elastic potential energy in the rubber cord and that is suppose is given as PE, which will be equal to half K x square. Now K is the spring constant for the rubber cord. K is the constant for rubber cord, and X is the extension in the cord. Extension in the cord, and which is given as 20 centimeter, 0.20 meters. So potential energy is equal to kinetic energy. Let's write it that since all the potential energy, that is because elastic potential is rather in the stretched cord, is converted into kinetic energy of the stone. Since all elastic potential energy in the stretched cord is converted into kinetic energy of stone. So we can write that potential energy is equal to kinetic energy, or we can say half k x square is equal to 4. We already know value of x, so we can write this as k will be equal to 8 divided by 0.20, and this gives us that k will be equal to 200 Newton per meter. So we found out the value of k, that is constant for the rubber cord. Now the Young's modulus of cord, we can write that the Young's modulus of cord modulus of the rubber cord. So we can write for the spring constant of k, spring constant k is given as k is equal to ya upon L, where this A is cross-sectional area, L is the original length, and which is given as 42 centimeters, so this will be 0.42 meters, and y is the Young's modulus. Y is Young's modulus. So we can find out the area. Area is equal to pi r square. We are given the radius is our diameter is given 6 mm, so we can write this as pi multiplied by 3 into 10 to the power minus 3 whole square. So we get the area will equal to 9 pi 10 to the power 6 meter square. Now simply substitute the values. K we got as 200, so 200 y we are supposed to find out. Area we got as 9 pi into 10 to the power minus 6, and length we also know is our 0.42. So we can write that our y is equal to, we have this 200 multiplied by 0.42 divided by 9 pi, and this is our 10 to the power minus 6. This gives us 2.97 into 10 to the power 6 Newton meter square, and we can write that y is approximately equal to 3 into 10 to the power 6 Newton meter square. Okay, and so we can say that the option number A is the correct option. So this is the closest value. So therefore we can say that option A is correct. So this completes the question. Thank you.